Hi guys, I've got a couple clips to look at with you to try to motivate the idea of the electric field. So let's go ahead and jump right into it. This first video I have again is from the MIT Physics Group Technical Services. Links will be in the description below. And let's go ahead and start playing this. So the setup here is they have a Van de Graaff generator, and let me just remind you what the Van de Graaff generator is. Essentially, there's a belt that runs down the center of this glass tube, and when he turns the Van de Graaff generator on, you'll see this thing turning away, and it essentially just rubs on a piece of the Van de Graaff at the top here, creating friction, and using that frictional force that we saw from rubbing a balloon or pulling a comb through our hair to strip charge, separate charge, and leave this metal sphere at the top charged up. So it's essentially just a device that gives me a nice metal sphere that has a large amount of charge built up on it. Over here he has a metal rod. And what he's going to do is he's going to take this apparatus that has two conducting balls tied together by an insulating rod. So the insulating rod is there just to keep the two balls physically separated. And he's going to connect them to this rod. Okay, so now the Van de Graaff generator is charged. It's being placed near this metal rod. We know what that's going to do. Imagine that the Van de Graaff generator has negative charge on it. It's going to pull those positive charges closer to this end of this conducting piece of metal, because opposite charges attract, leaving this end more negatively charged. And because these two conducting spheres are in contact with that metal rod, this one is going to become more positively charged, and this one is going to become negatively charged. And now when he removes it from this metal conductor, he's going to have two separately charged spheres that have been charged through magnetic induction, just like we saw with the demonstration where we had the two balls near each other and pulled them apart. And now what he's going to do is he's going to move that setup around the Van de Graaff generator. And what you can see is at any point in space that he picks, that positively charged sphere, that white sphere, will rotate itself to point towards the Van de Graaff generator. Makes some sense, right? The positive charge is always attracted to the positively charged Van de Graaff generator. But now what we can think about is the electric field. So we can imagine, right, field lines, lines that are emanating out from this Van de Graaff generator that point straight radially outwards from this Van de Graaff generator that essentially are encoding the space around that charged object and telling that dipole on the string how to orient itself. It's going to align itself with that electric field as it goes around. And so you can imagine using this little device as a probe to understanding how the electric field would point, right? This object is essentially going to align this rod along the direction of the electric field. Okay. So let's jump out of this demo and go into another video from Walter Lewin from MIT. And he's going to show you another visualization of the electric field.
And I will also show you the field configurations in the vicinity of two charges which have equal polarity. You may have seen this in high school with magnetic fields, with iron files. That's kid stuff. That's the easiest thing.
Right, so we're going to see that demonstration later this semester. But basically what he's going to do is show you a demonstration where we can visualize all those electric field lines around some charges for some specific system.
I bet you've never seen electric fields which are traced by these mysterious seeds. So I'll give you some light that may optimize the demonstration.
So here's the setup. He just has a little container that has some water inside of it, and it's filled with grass seed, just little grass seeds. And then there are some little electrodes inside of this that he's going to put charge on. So he's going to make one charge positive and one charge negative, and it's going to create an electric field in the vicinity of those charged objects. What's going to happen to the grass seed? Well, just like the neutral objects that jump up to the balloon due to polarization, each little grass seed, the positive charges in the grass seed are going to get pulled closer to the positive charges in the system, and the negative charges are going to get pulled to the negative side of the grass seed, and we're going to end up with some charge separation where the positive charges of the grass seed are located closer to one side and the negative are located on the other side, and we're going to end up with a small dipole. Each little grass seed is going to be a small dipole, just like the two spheres that were attached to the rod in the previous video. And that means in the electric field, the grass seeds are going to rotate themselves so that the positive charge will be pointing in one direction and the negative charges will all be aligned, and they're going to point along the direction of the electric field.
It is in a way so that it is chaos.
So first he just mixes the grass seeds to make sure there's random orientation.
The first thing you see is I'm going to make this, I believe it's going to be a dipole first, almost certain.
So right now there are no charges on those electrodes inside of this liquid.
We'll see how these grass seeds will form.
And you'll see as soon as he energizes and charges those objects, you see a very dramatic behavior. All the grass seeds aligns and you can see the electric field emanating from the positive, right? The electric field goes from the positively charged object to the negatively charged side of this electrode, and you can see these field lines returning nicely, right? So you can see the structure. And back here, the electric field goes out, returns back around, and you can see this clear visualization of the orientation of this electric field through space. And we call, right, we're going to describe the property of the space around these charged objects by this electric field property. So that's the end of today's video. We'll talk more about this in lecture. Thank you so much. Have a great day.